This video is about basic operations of the stack collection. A stack is a collection that retrieves elements in the opposite of the order in which they were added. You can add elements and remove elements from what's called the top of the collection. If you look at the diagram on this slide, the bottom of the stack contains a 1, and then the numbers 2 and 3 are stacked on top of that. So that means that the elements 1, 2, and 3 were added in that order to the stack. We speak about adding to a stack, we call it pushing onto the stack. And you can only push elements onto the top of the stack. So if you wanted to add a fourth element, it would go on top of the number 3. If you want to remove elements from a stack, you can also only remove them from that top area of the stack. So the top is really the only area of the stack that you can access or modify in any way. If you think about it for a moment, if you add the elements 1, 2, 3, 4, and the 4 is on the top of the stack, if you want to retrieve and remove the elements, you have to remove them in the opposite order, 4, 3, 2, 1. This means that the last element that you add is the first one that comes out when you start to remove. So some people refer to a stack as a last in, first out, or LIFO collection. The three fundamental operations that almost every stack implementation supports are called push, pop, and peek. Pushing means adding an element to the top of the stack. Popping means removing the element from the top of the stack and returning it. And peeking means examining the element that's on top of the stack without removing it. Java contains an implementation of stacks, a class that's called stack, in the java.util package. Here are some of the major methods that that class supports. As we said on the previous slide, it has methods named push, pop, and peek to match those three fundamental operations. When you construct a stack, you have to supply a type parameter indicating what type of data will be stored in the stack. And if we want to store primitive values like ints, we will use the wrapper classes such as integer or double with a capital D, as we may have seen with other collections so far, such as array list. The example on the slide here, I make a stack and push 3 integers, and then I pop one of them. The one that comes out is the last one that was added, the 17. Let's go to an editor and practice a little bit with stacks. Here I have a file with a main method. I'm going to construct a new stack. And I'm going to add several elements to the stack. Push 10 and 20 and 30. And then I'm just going to print the stack. If I compile and run this program, the output is 10, 20, 30. When stacks are printed on the console, the bottom of the stack is at the left and the top of the stack is at the right. So now if we want to remove some of the elements from the stack and examine them, I could say system.out.println stack.pop. And that's going to grab the topmost element of the stack, which is the 30, and remove it and return it, and I'll print it here. And then if I print the stack again, I'm going to see that the stack only contains 10 and 20. So the 30 is what comes out from pop, and the 10 and 20 remain on the stack. So if I repeated this sequence of commands right here, and I pop and print, then I will see that the output of the program is, originally I have 10, 20, and 30. I pop the 30. Now I have just 10 and 20. I pop the 20. Now I have just 10. I pop that, and now the stack is empty again. Now, people who are new to using stacks are more familiar usually with collections like array list, and so they want to do other operations on the stack, like grabbing elements from arbitrary indexes or something like this. But a stack is very limited in what operations it supports. You're not able to actually directly access this 20 or this 10. As long as the 30 is what's on top, that's the only element that you're allowed to access. Some students find that a little confusing or limiting, but I think the idea of a stack is that it only supports a few simple operations, but it's still able to be useful and solve various interesting problems. So I think the idea is not to try to find the operations that you're missing from another collection like array list, but to learn to embrace and use the operations that are provided in the stack, the simple operations like pushing and popping. There are a few other methods in a stack, such as size and isEmpty. If you want to ask how many elements are in the stack or whether the stack has any elements, you can do that. The peek method is useful. The peek method is like popping. It looks at the method that the element that's on the top of the stack, but it doesn't remove that element. So if I go back to this code here for a minute, if I want to see what's on top of the stack here at this point, it should be the 30, but I don't want to actually lose that element or delete it from the stack. So I can say stack.peak. And the interesting thing about peak is I could call peak several times, and that doesn't modify the state of the stack. So each one of these peak calls should print this 30 that's on top. Then when I call pop, that will also print the 30, but that one will actually remove the 30, so the stack will change afterward. So let's compile and run the program again. So you see all of these 30s that are printing out, these are the results of those peak calls. Peak, peak, peak. These 3 peak calls lead to these 3 outputs of 30 right here. And the fourth 30 comes from calling pop, but that one actually removes the 30. So now if we print the stack again, it has only 10 and 20 in it. So a pretty common way to process a stack is to loop over all of the elements, but you can't do it using the syntax that you might be desiring from array list. If we were using an array list, you could do something like this top piece of code right here. You could make a stack and then loop over each index from 0 to size and get the element at index I. That's what you would do with an array list. You can't do that with a stack. A stack simply doesn't allow you to access elements at arbitrary indexes. This code doesn't compile. It doesn't work. There is no get method of a stack. Instead, you simply have to use s.pop and process the element that you find when you pop the stack. But instead of doing a for loop from 0 to size, the much more common idiom is to do a while loop while the stack is not empty. So let me demonstrate using the program that we've been writing so far. I'll go back to our code editor, and I've pushed 10 and 20 and 30 here, and I will delete some of these commands underneath here. And instead of what I had before, I'll say while the stack isn't empty, I will print the result of s.pop. Maybe I'll add a little bit of output. I'll say the value is plus s.pop. Oh, sorry, the stack is named stack, not s. Yes. So now I run the program again, and it says the value is 30, the value is 20, the value is 10. And then the code stops. And of course, at the end of that code, if I print the stack, you know what that should print, right? If I print the stack, you know that the stack should be empty after this loop. So the stack should print just 2 brackets, 2 square brackets with nothing inside. The stack has no elements inside of it. So it does raise an interesting situation and problem of what if you want to print the stack without losing all of the elements inside of it? So that's something a little more advanced that we'll talk about a little bit later. But this is the more common idiom for processing the contents of a stack. Looping until the stack is empty and popping each element. That's the only way to retrieve these elements that aren't on the top anymore. Let's do an exercise together. Let's write a method called toCopies. It accepts a stack of integers as a parameter, and it modifies that stack so that it contains 2 consecutive copies of each element from the original stack. So for example, if the stack that we pass in contains 10, 20, 30 with the 30 on top, then after the call to the method, it should contain 2 copies of 10, 2 copies of 20, 2 copies of 30, and so on. And we're allowed to use one collection as auxiliary storage if we like to help us solve the problem. So how do we do this? Well, if we go to our editor and we want to start writing this method, public static void toCopies of a stack of integers named stack. Notice that the method returns void because we're going to modify the state of the stack that was passed in. It's passed in by reference. Therefore, if we make changes to it, then the client caller will see those changes. So how do we do it? Well, you could write a method that would grab each element and add 2 of them. I mean, you could do something like this, you know, int value, int element equals stack.peak. And then you could do stack.push element twice. You know, that sort of seems to be doubling. You know, you have 2 copies of one element there, but that's not really going to work. We need to do that for every element. So a lot of students try to write something like this, you know, for int I equals 0, I is less than stack size, I plus plus. Let's do this set of operations right here. Now, I want you to understand that that isn't really going to work because this is simply going to grab the top element and put 2 more copies of it on there. And we're just going to do that over and over again. That's not going to duplicate each element of the stack. So then people remember, well, you know, I'm not supposed to do for loops up to size. I'm supposed to do while not empty, right? So they come back and they change this code to say, while the stack isn't empty, I'll do this. But that's not going to work either, because if you think about it for a second, the stack is only growing. If the stack contains 10, 20, 30, then our code is going to do something like, well, I need to take out the 30 and put in 2 of them. Maybe you even say we should change this into pop. I mean, if we take out the 30 here and then we put in 2 copies of it, that seems to be doing something good. But then when the code wraps back around to continue working, we're just going to grab this 30 again and pull him out and put in 2 copies of him, and then pull this guy out and make 2 copies of him. And so we're just replicating this 30 incessantly. This isn't really doing what we want to do, which is to grab each element and the one below it and the one below it and make 2 copies of them. So how do we handle this? Well, remember that the problem description said that we can use an auxiliary collection to help us solve the problem. And here's where I think another stack would actually help us a lot. How about as we pull each element out of here, we put 2 copies of it into some other stack that we're keeping around on the side to help us with temporary processing. And then once we're done with this, we could copy this back to the original stack at the end. Here's the idea. Let's come back here and say stack of integers. S2 is a new stack of integers. And while the stack isn't empty, we're going to pop an element off of it, but we're going to put these new ones, the doubled copies of it, into S2. So if you think about it for a second, if the stack that got passed in was this, 10, 20, 30, what are the state of the 2 stacks going to be at the end of this while loop? Well, we're looping until the stack is empty, so there won't be anything in the original stack S. What's going to be in S2? Well, we remove the pop, which is 30, and we put 2 of them into S2. 30, 30. Then we remove the next pop, which is this 20. We put 2 copies of that, 20, 20, and then 10, 10. So S2 contains basically the mirror of what we want the stack to contain at the end, right? We want the stack at the end to contain 10, 10, then 20, 20, then 30, 30. So now we just need one more while loop that says while the S2 isn't empty, we're going to copy all of its contents back into S1 or stack. So I'll say stack.push S2.pop. So pop each element from here and put it into here, 10. Pop each element from here and put it into here, 10. Pop each element from here, put it into here, 20. So do you see how that's going to reverse back to the original stack? Let's test it out. If we go up here to the main method, we're pushing 10, 20, and 30. Let's call 2 copies stack. And then before and after doing so, we'll print the stack. Let's see if it works. I run the program. 10, 20, 30 becomes 10, 10, 20, 20, 30, 30.